Hello and welcome to lesson 3.4, modeling with sinusoidal functions. Today we're going to use the functions sine and cosine, which are called sinusoidal functions, to actually model trigonometric or periodic functions. And we're going to use the measurements in radians. Now, please realize that on the screen I have the variable t being used. Technically, you can use any variable you prefer. Also, the variables a, k, d, and c are the same variables that we've been using for many of our transformations. So you can use these to help you out in understanding what kind of transformations are actually being applied to the functions. So let's get right into it. Let's suppose I have this function right here, this blue function. And as you can see, I have also got the black function, y equals sine of x, overlaid on the same graph. So one of the things that we could talk about is what is called amplitude. Amplitude is half the distance from the maximum to the minimum. And it's usually defined by a positive value. Amplitude is often calculated by taking, again, your maximum height, subtracting your minimum height, and dividing by 2, as it is half the distance. Another part of this function is what we call our axis of curve. The axis of curve is the distance halfway between the maximum and minimum value. So as it is distance between the maximum and the minimum, you can calculate this value, which is going to be your c value, by taking the maximum plus the minimum and dividing by 2. The other parts of this is you have to actually calculate the period of the function. The period is just how long it takes for one full wave to repeat itself. You can calculate this by measuring distance from maximum to maximum, a minimum to a minimum, or where the function actually repeats itself. So here I'm going to draw a maximum and a dot on a maximum. And the distance right here, we can see, is going from 2 pi to pi, so that's pi units. This is what we call the period. Now, how does this relate to actually how stretched it is? Well, to figure out your k value, I'm going to write this down here, most of the time, sine functions or cosine functions have a period of 2 pi. This one is pi units long. So here you find out your value of k is equal to 2, which is a horizontal compression. So it's always going to be 2 pi divided by whatever the period would be. Now phase shifts, or your value for d, is always based on how many units you've moved from your original function over to your new function. Now for sine starts halfway between its maximum and minimum value, actually from your minimum to its maximum. So what you want to do is find a minimum, find a maximum, and find out the location halfway between that. So right here, you can see that this function is actually shifted right here horizontally 3 pi over 4 units to the right. So this is your phase shift, or one possible phase shift. Phase shifts can change and are always based on whatever function you're modeling it to. So if you're modeling to sine, this is what the phase shift would be. If you were modeling to cosine, you'd see how far it's translated. And you can even try to change your amplitude to a negative value, and that may change your phase shift as well. So let's take a look at an example of how we can use this. So the following data is recorded that shows the distance of the water's edge to the shoreline at the Bay of Fundy, which is rounded to the nearest meter. We're going to use this information to create a model to determine the distance from the water's edge based on time. So in order to define that, we need to define some variables. So let y represent the distance from the water's edge, in meters, and we're going to let x represent the time in hours. Now remember, in order to find some of these pieces of information for our item, we want to first probably calculate our amplitude. So to again calculate our amplitude, our value for A, we're going to take whatever the maximum value was, subtract the minimum, and divide by 2. So here our maximum value is 20, our minimum is 1. We're going to use those values. And we get 9.55. Figure out our axis of curve, similar process, just max plus min, divided by 2. $10.5, sorry. Calculator wrong. Okay. Next we want to use the period to figure out our phase shift. Well, right here, we don't have a minimum, we don't have a maximum. Sorry, we do have a minimum, we do have a maximum, but we don't have two of them. We can see the distance between from the minimum to the maximum is 12 hours. You can assume at 26 hours, going back down to 1. So there we have a period of 24 hours. Now that we have our period of 24 hours, we can figure out our value for k by taking 2 pi and dividing by 24. Okay, so last part. If we want to model this to cosine, let's say. If we want to model this to cosine, we find the best thing we do is we look for the time where we reach a maximum. So if you're modeling this to cosine, you lose your t value of 14. And therefore we'll get our equation now. So our equation with all our values is going to be 9.5 cosine pi over 12 x minus 14 plus 10.5. Now again, if you're going to model it to sine, you might want to use halfway between the 2 and the 14 to actually find that value, which would be about 8. And thus concludes this lesson.